Okay, checking your answers for part B. I've used the distance formula with the square root sign, so the d is the square root of x squared plus y squared. Filled in my x coordinate of 4 and my y coordinate of 6. You can choose to use brackets, but because they're both positive, it doesn't really matter if you use brackets here or not. You're going to get 16 plus 36, which is 52. So d is the square root of 52, and that would be units. That's our exact answer. And then approximately equal to, that's the dot above the equal sign, is approximately equal to 7.2 units. Now when I did part C, I chose instead to use just the Pythagorean theorem as I would normally remember it. And the reason I'm doing that is only because for some people, they remember the Pythagorean theorem, but for whatever reason, they're not good at memorizing, speaking for myself. So this other formula is a little bit of an extra thing to have to remember. So I just, for myself, just remember Pythagorean theorem, knowing that I'm working with my rise and my run. That's my distance squared, the hypotenuse squared. Put in my x values and my y values for my rise and my run. And this time you have to put the negative 12 in brackets because the negative does need to get squared. So negative 12 squared plus 11 squared, that came down to d squared equals 265. And then I square rooted both sides at that point and got d is approximately equal to 16.3 units. If I wanted to keep that exact, my d would be equal to the square root of 265 units. Okay, so now we're going to put this in an application. You have just won an all-inclusive vacation to a mystery destination. Destination A is at 123,54, destination B is at negative 78,75, and destination C is at negative 24, negative 168. Now the only catch to this vacation is that you have to pay for your airfare. Which destination should you choose if you wish to minimize the cost of the flight? If, I have a typo, of course I do, if the cost is based on the distance flown. So in other words, we want the shortest distance because the shortest distance, in this case, if it's based on the distance flown, will be the cheapest one. And right now, Mrs. Logan does not have a lot of extra money, so she's got to take that into consideration. All right, so for A, we could get its distance. So the distance, memorizers, are going to do the square root of x squared plus y squared, which A, the x coordinate, is 123, so we would have 123 squared, plus the y, which is at 54. 54 squared, and I make sure I extend that square root sign all the way across. 123 squared is 15,129. So I'll write that in, 15,129 plus, and then 54 squared is 2,916, and I want to square root that sum, and I get 18,045. So that's the exact value, which is approximately equal to 134.33 units, or 0.3 units. I don't know if you can hear my dog barking in the background, but I think she thinks there's a bunny outside that she would like to go and chase. All right, for point B, you're going to calculate its distance, and then of course your smallest one wins. So you can put me on pause if you haven't already done this question. Try those other ones out and see how you do. And I'll put a solution up in a moment here. Put me on pause first, and then when you hit play, it should come up. Okay, so I've calculated the other two distances, and comparing them, this is our smallest distance here, so it should be our cheapest flight if the flight's based on the distance flown. Okay, so choose destination B. All right, next here. The point 5 comma y is 13 units from the origin. Determine the value of y. So this time I haven't given you all of the coordinates here. I've only given you the x coordinate. You know x is the 5. and it's from the origin still, so that my formula of d equals the square root of x squared plus y squared should still apply to this question. And I'm getting really messy with my writing here, sorry about that. I can just fill in what I know. This time I know my distance. My distance is 13. It can go where the 13 is, or where the d is. I know the x coordinate would be a 5, so that's going to be 5 squared, plus the y coordinate, which I don't know, and I'm going to keep as a variable for now. Okay, so we get this. What I need to do is I need to solve this for y. So I'm going to use my equation solving skills to undress the y, to get y all by itself, to get it naked. So to do that, I'm going to undo the square root sign by doing its opposite operation. The opposite of square rooting is an exponent of 2. So I'm exponenting 2 to both sides. 13 squared is 169, and that's going to equal, the square root and the square cancels out, and it leaves me with the 5 squared plus y squared. That's a plus sign, y squared. Okay, and then to get y squared by itself, the 5 squared is being added to it. 5 squared is really 125. So for those of you who like to clean up your numbers first, we could do that first. Then I could subtract 25 from both sides to get rid of it on the right side of the equal sign. So 169 take away 25 is 144. So this becomes 144 equaling y squared. And now to get y by itself, it's being squared, so to undo a square, we're going to square root. And when we square root, there's always two answers. There's always a positive and a negative answer. So positive or negative square root gives me plus or minus 12 when I positive or negative square root the 144. So the y might be 12. That means my point, the point would be either 5 comma positive 12, and if I put that in my distance formula, I'd get 13, or the point could be 5 comma negative 12, because it also would give a point that is 13 units from the origin.